We're going to take a look at a specific heat problem. When we define specific heat, it is the amount of heat in joules needed to raise 1 gram of a substance 1 degree Celsius. We use the variable capital C with a subscript of P to define specific heat, and our units of measurement are the ones that I just wrote down. The equation that we use is heat is equal to the mass of the substance times its specific heat times the change in temperature when it either absorbs or releases heat. So how does this look in a problem? Let's take a look at this problem. When we read this problem, they want to know to what temperature. So that is actually our final temperature. Will a 50 gram, that's our mass, piece of glass raise to if it absorbs that amount of heat, so that's our Q, and its specific heat capacity, so that is our specific heat, when the initial temperature of the glass, so that's our initial temperature, is 20 degrees Celsius. They've given us a lot of variables, and this is actually a two-step problem. So let's take a look at how we would solve it. We know our mass. We know our mass is 50 grams, so let's write that down. We've got 50 grams. We know how much heat it absorbs. Q is our heat. So our heat is 5275 joules. They've given us our specific heat capacity, which is 0.5 joules per gram degrees Celsius. And they've given us our initial temperature, which is 20 degrees Celsius. We don't know what the change in temperature is. So if we look at our specific heat formula, which is this, we're actually solving for change in temperature. Let's rearrange this formula so that I've got that variable all alone on one side of the equation, which means that I've got to divide by these two, by this variable and this mass and specific heat, so that they cancel out. And when I do that, I have delta T is equal to Q divided by mass times specific heat. So I have rearranged, I have rearranged this formula to read delta T is equal to Q divided by mass times specific heat. Or I've got 5275 joules divided by 50 grams times the specific heat, which is 0.5 joules per gram degrees Celsius. And let me get my calculator. When we do the math, I get a change in temperature. Joules cancels out, grams cancel out. So I get a change in temperature of 211 degrees Celsius. Now I'm going to plug that and my initial temperature into this formula. So I've got 211 degrees Celsius is equal to, I'm trying to find the final temperature, and I have the initial temperature of 20 degrees Celsius. So if I add 20 degrees Celsius to both sides, I get 231 degrees Celsius is this will cancel out, is equal to my final temperature. Okay? So my final answer is going to be 231 degrees.